November 23, 1942, Mejez El Bab, Tunisia. Major Klaus Hoffmann's boots crunched across the sandy battlefield as he approached the disabled Panzer IV, its right track shredded by something he'd never encountered before. The tank commander, Oberfeldwebel Ernst Weber, sat on the turret, smoking nervously. American infantry, Herr Major. One man, maybe 300 meters away. Hoffmann examined the entry wound. A circular hole, 12 centimeters across, punched clean through the side armor. The edges were smooth, almost melted. No fragmentation pattern, no artillery crater nearby. This wasn't a mine. This wasn't an anti-tank gun. This cannot be an infantry weapon. No foot soldier carries something that penetrates 120 millimeters of armor. He climbed onto the tank and peered inside. The shaped charge jet had liquefied the interior steel, spraying molten metal across the crew compartment. 2 men had died instantly. The ammunition hadn't cooked off, pure luck. But the penetration depth was extraordinary. Whatever made this hole had focused its explosive force into a superheated stream capable of defeating the Panzer IV's armor as easily as a knife through butter. "Did you see what he fired?" Hoffmann asked. "A tube, Herr Major, like a stovepipe. He held it on his shoulder." Hoffmann straightened. For 3 years, German Panzers had ruled European battlefields because infantry couldn't touch them. Anti-tank rifles were useless against modern armor. Satchel charges required suicidal close approaches. The Wehrmacht's doctrine assumed foot soldiers were helpless against tanks. That's why blitzkrieg worked. Infantry scattered when armor appeared. But if the Americans had developed a man-portable weapon that could kill tanks at 300 meters, everything changed. Every German tank crew in North Africa was suddenly vulnerable to every American rifleman. The tactical mathematics of armored warfare, the calculations that made panzer divisions unstoppable, had just been rewritten. Hoffmann pulled out his field notebook and sketched the entry wound, noting dimensions and characteristics. Somewhere in the scrubland ahead, American soldiers were carrying a weapon that shouldn't exist, a weapon German intelligence had never mentioned, a weapon that, by all engineering logic, a single man shouldn't be able to carry and fire. Whatever it was, the Americans had just given their infantry the power to challenge Germany's greatest tactical advantage, and nobody in the Wehrmacht High Command knew it existed. The journey to Mejez El Bab had begun 10 months earlier, in December 1941, at the Aberdeen Proving Ground in Maryland. Lieutenant Edward Ull of the U.S. Army Ordnance Corps stared at the problem that had stumped American weapons designers for 2 years. The War Department wanted a man-portable anti-tank weapon. Every combatant nation needed one. Infantry faced tanks with nothing but grenades and prayers. The British had the Boys anti-tank rifle, 14 kilograms of awkward steel that barely scratched modern armor. The Germans used the Panzerschreck 39, equally useless against anything heavier than light tanks. The Soviets had developed anti-tank rifles that broke soldiers' shoulders and tanks' paint jobs in equal measure. But America had Charles Munro's shape charge research from 1888, recently weaponized by Swiss inventor Henry Mohaupt. Shaped charges didn't need high velocity or heavy projectiles. They needed proper geometry, a cone-shaped hollow in the explosive that focused detonation energy into a superheated jet capable of penetrating armor plate far thicker than the charge itself. Physics, not brute force. On December 14, 1941, 1 week after Pearl Harbor, O met with Lieutenant Colonel Leslie Skinner at Aberdeen. Skinner had been experimenting with Mohaupt's shape-charge grenades, achieving remarkable penetration against test armor. The problem was delivery. Throwing grenades at tanks was suicide. Rifle grenades lacked range. What they needed was a small rocket motor. The mathematics were straightforward. A 60-millimeter diameter shape charge weighing 1.6 kilograms could penetrate 120 millimeters of armor plate if properly designed. The M6 rocket motor, developed for signal flares, could push that warhead to 300 meters with acceptable accuracy. All they needed was a launch tube. O grabbed a discarded artillery shell casing from the test range. The diameter matched the rocket motor perfectly. He welded a crude shoulder stock to one end, added simple iron sights, and drilled a hole for the electrical firing mechanism. Total fabrication time, 4 hours. Total weight, 6 kilograms. On December 24, 1941, O fired the first prototype at a tank hole placed 100 meters away. The rocket whooshed from the tube, trailing fire, struck the armor, and detonated. When the smoke cleared, a perfect circular hole, 11 centimeters across, penetrated completely through 100 millimeters of steel plate. Skinner examined the result and smiled. It looks like Bob Burns' musical instrument. Burns was a comedian who played a makeshift trombone he called a bazooka, a name derived from bazoo, slang for mouth. The crude metal tube in Ull's hands looked exactly like Burns' comedic prop. The name stuck instantly. The Army gave them 30 days to perfect the design. By February 1942, the M1 Bazooka entered mass production. The final design was elegant in its simplicity. A 1.54-meter smooth-bore steel tube weighing 5.9 kilograms. The M6A rocket, 2.36 inches in diameter, carrying a 0.9-kilogram Composition B shaped charge warhead, weighed 1.6 kilograms and could penetrate 119 millimeters of armor at any range up to 300 meters. The rocket motor burned for 0.3 seconds, reaching 83 meters per second. An electrical firing circuit used a simple trigger magneto. 2 men operated it, one aimed and fired, the other loaded and connected the battery-powered ignition wires. Unit cost, $42.50. A Sherman tank cost $44,000. America could produce 1,000 bazookas for the price of one tank. By June 1942, the U.S. Army had manufactured 5,000 bazookas and distributed them to training units. By October, 10 months after Ull's first prototype, production reached 5,000 per month. Infantry companies received standard allocations, 3 bazookas per company, 9 per battalion. American foot soldiers now carried something German Panzers had never faced. But the weapon remained classified top secret. No photographs, no public announcements. German intelligence had no idea it existed. On November 8, 1942, Operation Torch, the Allied invasion of North Africa, landed American forces in Morocco and Algeria. Each assault battalion carried bazookas in their equipment manifests, sealed in wooden crates marked Launcher Rocket AT M1. Most soldiers had never seen them. Training had been rushed. Some units received their bazookas on the transport ships crossing the Atlantic, with hasty instruction from officers who'd only fired them once themselves. The first combat encounter came 15 days later, near Medjez El Bab, Tunisia, when advancing American infantry met German armor screening Axis positions. Private Robert Patterson of the 1st Battalion, 6th Armored Infantry Regiment, found himself 200 meters from a Panzer IV advancing down a dirt road. Patterson had fired a bazooka exactly twice during training. His loader, Private First Class Joseph Murphy, had never even touched one. But doctrine was clear. Aim for side or rear armor where plates were thinnest. Avoid frontal shots where armor exceeded bazooka penetration capability. Fire from concealment, relocate immediately after shooting. Patterson shouldered the tube. Murphy connected the firing wires, and Patterson centered the iron sights on the Panzer's right side as it turned to traverse its turret. He squeezed the trigger. The magneto sparked. The rocket motor ignited with a sharp crack and a blast of flame that scorched the ground behind them. The rocket streaked across the scrubland, trailing white smoke, and struck the Panzer amidships just below the turret ring. The shaped charge detonated. The copper cone liner converted into a superheated jet moving at 8,000 meters per second, punching through armor plate and spraying molten metal through the crew compartment. The Panzer lurched to a halt, smoke pouring from the entry wound. The crew bailed out within seconds. Patterson and Murphy stared at each other in shock. They'd just killed a German tank, something that should have required a towed anti-tank gun, air support, or friendly armor. Instead, two infantrymen with a metal tube had done it from 200 meters away. By November 23, 3 more American soldiers had destroyed 6 German tanks using the mysterious new weapon. Wehrmacht field reports described American rocket tubes and shoulder-fired armor penetrators. German tank commanders began receiving warnings about Panzerfaust-ähnliche Waffen, bazooka-like weapons. But nobody understood what the Americans had developed or how it worked. The bazooka's effectiveness became apparent across Tunisia throughout December 1942. Near Tiburba on December 3, Sergeant William Baumer's squad encountered 4 Panzer III medium tanks advancing toward American positions. Armed with 7 M6A1 rockets, Baumer destroyed 2 tanks in 8 minutes from a concealed position 250 meters away. The remaining Panzers retreated. German after-action reports noted infantry anti-tank rockets of unknown type and requested intelligence analysis. At Longstop Hill on December 23, 3 separate American bazooka teams engaged German armor supporting a counterattack. Private Edward Riley knocked out a Panzer IV with his second shot at 175 meters. Corporal James Henderson destroyed a Stug 3 assault gun with a perfect side hit at 200 meters. Staff Sergeant Anthony Russo disabled a Panzer III by destroying its tracks, immobilizing it for subsequent artillery strike. German casualties: 3 armored fighting vehicles destroyed, 1 disabled. 14 crew killed or wounded. American casualties: 0. Cost of ammunition expended: 6 rockets at $12 each, $72. The Germans began recovering unexploded M6A1 rockets from the battlefield. Intelligence officers photographed them, measured them, and shipped samples to weapons testing facilities in Germany for analysis. What they found baffled them. The Americans had developed a man-portable rocket launcher, something German engineers had considered but deemed impractical due to backblast dangers, rocket motor reliability issues, and shape charge manufacturing complexity. Yet here was physical proof. A simple steel tube, an elegant electrical firing system, and a shape charge warhead achieving penetration that rivaled German 50mm anti-tank guns. Captured interrogation transcripts revealed German confusion. One Panzer IV commander, Lieutenant Friedrich Koch, captured after his tank took a bazooka hit near Kasserine Pass, told American interrogators, "We thought your infantry had anti-tank guns concealed in the rocks. When we learned it was shoulder-fired, I could not believe it. How do you manufacture shaped charges so quickly? We have explored this technology for years." The answer was American industrial capacity. By January 1943, U.S. factories were producing 8,000 bazookas per month at facilities in Illinois, Pennsylvania, and New Jersey. The M6A1 rocket entered production at General Electric, Eastman Kodak, and specialized munitions plants. Monthly rocket production exceeded 100,000 rounds. Cost per rocket, $12. The Americans were mass manufacturing precision-guided anti-tank weapons at prices Germany couldn't match even for rifle ammunition. German tank crews adapted their tactics. Panzers began advancing with infantry screens to spot bazooka teams before they could fire. Tank commanders kept vehicles at maximum range from American positions. But this reduced their own effectiveness, since panzer cannon accuracy degraded beyond 800 meters, while bazooka teams could shoot accurately at 300 meters. The defensive advantage shifted to American infantry. By February 1943, Wehrmacht tactical doctrine acknowledged American rocket infantry weapons as a significant threat requiring specialized countermeasures. Every German tank crew in North Africa knew that American foot soldiers could kill them. The psychological impact was profound. Panzers that had operated with impunity in France, Poland, and early Russia now faced a battlefield where every enemy rifleman might be carrying a weapon that could penetrate their armor. But the Americans' advantage depended entirely on the Germans not understanding how the bazooka worked. Once German engineers analyzed captured examples and reverse-engineered the design, they could produce their own version, and German industrial capacity, while smaller than America's, was still formidable. That understanding came sooner than the Americans hoped. But by mid-1943, the tactical surprise had ended, and Germany's response proved the bazooka's effectiveness better than any American field report could. On May 7, 1943, at the Kummersdorf weapons testing facility outside Berlin, SS Hauptsturmführer Dr. Heinrich Langweiler examined 3 captured M1 bazookas arranged on steel tables. His technical team, 8 weapons engineers from Rheinmetall and Mauser, had spent 6 weeks analyzing every component. The shaped charge warhead design, the electrical firing system, the rocket motor specifications, the launch tube metallurgy. Langweiler ran his hand along one tube smooth bore. "This is brilliant in its simplicity," he said to his chief assistant, Oberleutnant Werner Schmidt. "They've eliminated everything unnecessary. No complex recoil mechanisms, no breech-loading systems. Just a tube, a battery, and the rocket motor's propellant blast venting safely behind the operator." Schmidt nodded. The shaped charge achieves 120 mm penetration with only 850 grams of composition B. Our own tests confirm American combat reports. This weapon can defeat any tank's side armor at 250 meters. The examination revealed uncomfortable truths. American engineers had developed the bazooka from concept to battlefield deployment in less than 1 year, December 1941 to November 1942. German weapons development typically required 3 to 4 years from specification to production. The Americans had achieved in months what German bureaucracy couldn't accomplish in years. More disturbing, the bazooka's unit cost of $42.50 meant America could produce them faster than Germany could destroy them. Wehrmacht intelligence estimated U.S. production at 60,000 units by mid-1943, enough to equip every American infantry battalion in both European and Pacific theaters with 3 times their standard allocation. German forces in Tunisia had captured perhaps 200 bazookas. The Americans had 59,800 more. "We must produce our own version," Langweiler told the Waffenamt High Command in his report dated May 15, 1943. "American infantry now possesses effective anti-tank capability that negates our armored advantage. Every delay costs German lives." The result was the Panzerschreck, tank terror, officially designated Raketen-Panzerbüchse 54. German engineers scaled up the American design, increasing the rocket diameter to 88 mm for greater penetration and extending the launch tube to 1.64 meters. The RPZB-54 fired an 88 mm shaped charge rocket weighing 3.3 kilograms,
more than twice the M6A's weight, capable of penetrating 160 millimeters of armor at 150 meters. It was heavier, 9.5 kilograms versus the bazooka's 5.9 kilograms, and more powerful, reflecting German engineering philosophy. If Americans could do it, Germans would do it better. But development took time. The first Panzerschreck units reached Wehrmacht frontline forces in October 1943, 17 months after American bazookas debuted in Tunisia. In warfare, 17 months is eternity. During that period, American infantry killed German armor with impunity across North Africa, Sicily, and Italy, while German foot soldiers still relied on magnetic mines and desperate close-quarters attacks. Lieutenant Franz Weber of the 305th Infantry Division, killed in Sicily in July 1943, wrote in his final letter home, "The Americans have given their soldiers weapons that make our tanks afraid. Every time Panzers support our positions, we know American infantry will destroy them within minutes. But we have no equivalent weapon. We throw grenades at their Shermans and die. Why does Germany not give us what the Americans give their men?" Weber never knew that German engineers were developing exactly that weapon. He died 2 months before the first Panzerschrecks reached the front. American soldiers noticed the German copy immediately. Sergeant Michael O'Brien, 1st Infantry Division, encountered a Panzerschreck team near Salerno in September 1943. They had something that looked like our bazooka, but bigger. Heavier tube, bigger rocket. German engineering. They couldn't just copy us. They had to make it complicated. Worked fine, but our guys were faster on the draw because our weapon was lighter. The American design philosophy, light, simple, mass-produced, proved superior to German over-engineering. The bazooka weighed 5.9 kilograms. A single soldier could carry it plus 6 rockets, 9.6 additional kilograms, for 15.5 kilograms total. The Panzerschreck weighed 9.5 kilograms. Its heavier rockets meant soldiers carried only 4, 13.2 kilograms, for 22.7 kilograms total. American bazooka teams were more mobile, carried more ammunition, and engaged targets faster. By D-Day on June 6, 1944, the U.S. Army had manufactured 476,628 bazookas.
They equipped every infantry company in the European theater of operations, every Marine Corps rifle company in the Pacific, and filled reserve stockpiles in the United States, Britain, North Africa, and Australia. American factories produced bazookas faster than combat consumed them. Germany manufactured approximately 289,000 Panzerschrecks between October 1943 and May 1945. Impressive production, but 18 months behind American deployment. The tactical initiative, the period when one side possesses a weapon the enemy cannot counter, belonged to the Americans for 18 critical months that spanned the invasions of Sicily, Italy, and Normandy. The Germans had created an excellent weapon, but they'd created it after analyzing the American weapon that had already changed infantry warfare. The student had copied the teacher's breakthrough, and in doing so, admitted the teacher had been right.
The requirements that created the bazooka originated in November 1941, 1 month before Pearl Harbor, when the U.S. Army Ordnance Department issued Specification OS-48, Infantry Anti-Tank Weapon Man-Portable. The specifications were precise. Weight, maximum 7 kilograms combat loaded. Range, effective 250 plus meters. Penetration, minimum 75 millimeters armor plate at impact angle 90 degrees. Crew, maximum 2 men. Training time, maximum 4 hours to basic proficiency. Unit cost, maximum $50. Strategic context shaped these requirements. American war planners knew the United States would fight in Europe against German armor and in the Pacific against Japanese fortifications. American infantry needed weapons they could carry through bocage hedgerows in France and jungle trails in the Philippines. Heavy anti-tank guns that required truck or trailer transport were useless in terrain where roads didn't exist. The designer team, Lieutenant Colonel Leslie Skinner and Lieutenant Edward Uhl, faced the impossible choice that defines all weapons engineering: effectiveness versus practicality. A shaped-charge warhead could theoretically penetrate any armor thickness, but only if properly designed. Charles Munro's research from the 1880s had demonstrated that explosive-lined metallic cones focused detonation energy into a high-velocity jet, the Munro effect. Swiss inventor Henry Mohout had weaponized this principle in the late 1930s, creating shaped-charge grenades that penetrated armor plate far thicker than conventional explosives could defeat. The physics worked. The challenge was delivery. The mathematics were brutally simple. To penetrate 75 millimeters of armor, the shaped charge needed at least 700 grams of high explosive, with a copper cone liner of specific geometry, roughly 60 millimeters. The warhead assembly, including fusing mechanism and stabilizing fins, weighed approximately 1.4 kilograms. The rocket motor to deliver this warhead 250 meters required 150 grams of propellant and steel casing, adding another 200 grams. Total projectile weight 1.6 kilograms. A launch tube strong enough to withstand rocket motor ignition without rupturing required steel walls at least 3 millimeters thick. A tube 1.5 meters long and 60 millimeters with that wall thickness weighed 4.5 kilograms. Add firing mechanism, sights, and shoulder stock, 1.4 kilograms. Total weapon weight 5.9 kilograms, well within the 7 kilogram specification. But these calculations revealed the fundamental trade-off. Every kilogram added to the weapon reduced the number of rockets a soldier could carry. Every millimeter added to the launch tube diameter increased weight proportionally. Every meter added to effective range required heavier rocket motors. Skinner and Uhl had to choose: build a heavy weapon with long range and massive penetration, or build a light weapon that infantrymen would actually carry into combat. They chose lightness. The M1 Bazooka sacrificed range beyond 300 meters, where infantry accuracy degraded anyway, and penetration beyond 119 millimeters, sufficient for all side and rear armor in 1942, in exchange for a weapon 2 soldiers could carry with ammunition through any terrain. The design philosophy prioritized infantry mobility over engineering perfection. This choice reflected deeper American military thinking. U.S. doctrine emphasized combined arms warfare: infantry, armor, artillery, and air power working together. The bazooka didn't need to kill every enemy tank in every situation. It needed to give infantry a fighting chance when friendly armor wasn't available. It needed to work when soldiers were tired, scared, and under fire. It needed to be simple enough that conscripts with 8th grade educations could operate it after 4 hours of training. German engineers examining captured bazookas in 1943 saw this philosophy and couldn't replicate it. German military culture demanded technical perfection. When Rheinmetall designed the Panzerschreck, they improved everything: bigger warhead, longer range, heavier penetration. The result was technically superior and tactically inferior because soldiers couldn't carry it as easily. Colonel Skinner defended his design choices in a post-war interview. "We weren't trying to build the perfect anti-tank weapon. We were trying to build a weapon perfect for American infantrymen. Light enough to carry, simple enough to maintain, effective enough to matter. The Germans built a better rocket launcher. We built a better infantry weapon. There's a difference." The justification was pragmatic. In 1942, American industrial capacity could produce simple weapons faster than complex ones. Mass production favored standardized components and straightforward assembly.
The bazooka used commercially available steel tubing, simple stamped metal parts, and electrical components from existing inventory. A factory could convert from producing pluming fixtures to producing bazookas in weeks. The Panzerschreck required specialized heavy-gauge tubing, custom machining, and quality control that German industry, already stretched by war production demands, struggled to provide. By mid-1943, the Americans were producing 10,000 bazookas monthly at costs below $40 per unit. Germany was producing perhaps 4,000 Panzerschrecks monthly at costs exceeding 70 Reichsmarks, approximately $28 in 1943 dollars, but material costs in Germany were heavily distorted by wartime shortages. American production efficiency proved that choosing simplicity over perfection wasn't compromise, it was strategic brilliance. The bazooka's tactical impact became mathematically apparent across every theater where American forces engaged armored vehicles. The Battle of Kasserine Pass, February 14 to 25, 1943, provided the first comprehensive test. German forces under General Feldmarschall Erwin Rommel attacked inexperienced American units with combined armor and infantry. U.S. forces suffered tactical defeats, but bazooka teams inflicted disproportionate casualties on German armor. On February 19, near Jebel Lasuda, Technical Sergeant Charles Grant's squad engaged 8 Panzer IV tanks advancing on American positions. Grant had 3 bazookas and 21 rockets. Over the next 40 minutes, his teams destroyed 3 Panzers and damaged 2 others. Cost: 7 rockets at $12 each, $84. Value of destroyed German armor: approximately 900,000 Reichsmarks, roughly $360,000 in 1943 dollars. Return on investment: 4,285 to 1. At Spaetla, on February 17, Corporal Robert Palmer ambushed a German supply column supported by 2 Stug 3 assault guns. Palmer destroyed both assault guns with 4 shots from 200 meters, then escaped before German infantry could locate his position. The ammunition trucks burned for 6 hours. German losses: 2 assault guns, 11 supply trucks, 43 tons of ammunition, 14 soldiers killed, 9 wounded. American losses: 4 expended rockets. The pattern repeated across Sicily in July-August 1943. During the Battle of San Fratello on August 8, Private First Class James Henderson destroyed 4 Italian M13/40 tanks in 20 minutes using 7 rockets. Italian armored forces, already demoralized, began abandoning operational tanks when American infantry approached, fearing bazooka attacks they couldn't counter. But the mathematics of attrition truly revealed the bazooka's effectiveness in the Italian campaign, September 1943 through May 1945. At Salerno on September 9, 1943, Company F, 2nd Battalion 143rd Infantry Regiment faced German counterattack by the 16th Panzer Division. American forces had established a precarious beachhead. German Panzer IVs and Tiger I heavy tanks advanced to drive the Americans back into the Mediterranean. Company F had 12 bazookas distributed among its 3 rifle platoons. The battle began at 6:15. German tanks advanced in 2 columns along the coastal road. First contact came at 800 meters, beyond bazooka range. American positions absorbed 75mm cannon fire while bazooka teams waited in concealment. At 6:42, lead Panzers reached 300 meters. Sergeant William Patterson's team fired first, striking a Panzer IV in the right track assembly.
The tank slew sideways and stopped, blocking the road. Second shot penetrated the engine deck, mobility kill. Third shot missed, rocket impacting dirt embankment. Fourth shot struck turret ring, catastrophic kill. Crew bailed out. At 6:45, 4 more bazooka teams opened fire simultaneously from concealed positions flanking the road. Within 90 seconds, 6 German tanks were burning or disabled. The Tiger I, invulnerable to bazooka frontal armor, pivoted to retreat and took a rocket through its thinner rear plate. The shaped charge penetrated the engine compartment but failed to ignite fuel. The Tiger withdrew, trailing smoke, while remaining Panzers pulled back beyond effective range. Total engagement time, 8 minutes. German losses, 3 Panzer IVs destroyed, 4 damaged, 1 Tiger damaged, 19 crew killed, 12 wounded. American losses, 0. Ammunition expended, 19 rockets, $228 worth of ordnance. Company F held the Salerno beachhead. German commanders reported effective American anti-tank weapons had made armored assault impractical without infantry clearing operations first, negating the speed advantage that made armor decisive. This scenario repeated across Italy. At Monte Cassino in January-May 1944, American and Allied forces used bazookas to destroy 127 German tanks and assault guns over 4 months. At Anzio in February-March 1944, bazooka teams knocked out 89 German armored vehicles. Each engagement demonstrated the same pattern. German armor approached American positions. Bazooka teams waited until range closed to 200 to 300 meters. Shaped charges punched through side or rear armor. German tanks died. Failed modifications attempted to restore German armored superiority. In March 1944, Panzer IV and Tiger tanks began receiving additional armor plates welded to hull sides, Scherzen plates, designed to defeat shaped charge penetration by detonating warheads prematurely. The additions increased vehicle weight by 800 kilograms, reducing mobility and mechanical reliability. And they didn't work.
Bazooka teams adjusted aim points, targeting areas where additional armor was impractical: engine decks, turret rings, track assemblies. Mobility kills were as effective as catastrophic kills. Disabled tanks blocked roads and required recovery efforts that exposed German forces to artillery fire. By late 1944, German tactical doctrine acknowledged that armor unsupported by infantry was vulnerable to American bazooka teams. But Wehrmacht infantry strength was declining due to Eastern Front losses. Tanks advanced without adequate infantry screens because infantry wasn't available. American bazookas killed them anyway. The Battle of the Bulge, December 16, 1944, January 25, 1945, showcased the bazooka's effectiveness in defensive operations. German forces attacked through the Ardennes with 1,400 tanks and assault guns, the largest German armored force since 1941. They faced American infantry divisions equipped with 2,847 bazookas according to U.S. ordnance records. At Bastogne, surrounded American paratroopers used bazookas to destroy 53 German tanks during the siege. Staff Sergeant Thomas Mackenzie's squad, 101st Airborne Division, knocked out 7 Panzer IVs in 2 days with 14 rockets. Mackenzie's after-action report: "They kept coming and we kept shooting. Every tank that got close enough died. Simple as that." At Elsenborn Ridge, Lieutenant Stephen Trupper's bazooka teams destroyed 23 German tanks over 3 days, creating a roadblock of burning armor that channeled subsequent attacks into prepared killing zones. Trupper survived the war and wrote in his memoir, "The bazooka saved our lives. No fancy tactics, no heroic charges. Just good positions, patient crews, and a weapon that worked every single time." The final accounting was devastating for German armor. In the Battle of the Bulge, Wehrmacht forces lost approximately 600 tanks and assault guns to all causes. American after-action assessments attributed 187 confirmed kills to bazooka teams, 31% of total German armor losses from a weapon that cost $42.50 per unit. Famous incidents demonstrated the bazooka's psychological impact. On December 18, 1944, near Stavelot, Belgium, Private Bernard Macy of the 291st Engineer Combat Battalion, alone, separated from his unit, encountered SS Obersturmbannführer Joachim Peiper's column of Tiger II heavy tanks. Macy had 1 bazooka and 2 rockets. He destroyed the lead Tiger's tracks with his first shot, blocking the narrow road. Second shot missed. Macy ran. But the blocked road delayed Peiper's entire column by 3 hours, time that allowed American reinforcements to establish defensive positions that ultimately stopped Peiper's advance. 1 private with 2 rockets altered the battle's outcome. By war's end, U.S. Army records credited bazookas with 3,148 confirmed tank and assault gun kills in the European theater, plus another 1,873 in the Mediterranean theater. These numbers don't include thousands of mobility kills, tanks damaged and abandoned, or suppression effects, German armor that refused to advance because bazooka teams were known to be present. The human cost was stark. German tank crews who had operated with confidence in 1940-1942 entered 1944-1945 knowing that every American infantry position might contain weapons that could kill them. Panzer crew morale collapsed. Survival rates plummeted. Experienced crews died. Replacement crews died faster. Obergefreiter Hans Schmidt, Panzer IV driver captured in France in July 1944, told interrogators, "We are dead men. The Americans shoot their rocket tubes and we burn. Every time. There is no defense. We die and they replace us and the new crews die. The war is over and we are just waiting for the rocket that kills us." The bazooka had done exactly what Colonel Skinner intended. It gave American infantry the power to challenge enemy armor. The cost was measured in German lives, German tanks, and German hope. Production statistics tell the bazooka's story in numbers that military historians still find remarkable. Between December 1941 and August 1945, American factories manufactured 476,628 M1 and M1A1 bazookas across all variants. The M1, original model, accounted for 112,790 units produced between May 1942 and December 1942. The M1A1, improved electrical firing system, reinforced tube, accounted for 59,922 units produced January-June 1943. The M9, simplified design, longer tube, improved sights, accounted for 277,819 units produced July 1943 through war's end. The M9A1, weatherproofed electrical system, folding stock for airborne forces, accounted for 26,087 units produced March 1944, August 1945. Distribution spread across every American combat theater. The European Theater of Operations received 189,443 bazookas, approximately 40% of total production. The Mediterranean Theater received 94,721 units, 20%. The Pacific Theater received 143,298 units, 30%. The remaining 49,160 units, 10%, went to training facilities in the United States, reserve stocks, and Lend-Lease shipments to allied nations including Britain, Free France, and China. Loss rates were remarkably low. U.S. Ordnance Department records indicate approximately 89,000 bazookas were destroyed, damaged beyond repair, or captured by enemy forces between 1942-1945, roughly 19% of total production. This means 81% of all bazookas manufactured survived the war, either in active service or in stockpiles.
The robust steel construction and simple mechanical design proved extremely reliable. Soldiers reported that bazookas functioned in temperatures from -30 degrees Celsius to +50 degrees Celsius, in mud, snow, sand, and jungle humidity. The weapon just worked. Crew casualties were proportionally low compared to other infantry weapons. The bazooka's 300-meter effective range allowed teams to engage targets from concealment and distance. After firing, teams could relocate before enemy forces pinpointed their position. Records from the 1st Infantry Division show that bazooka operators suffered casualty rates 40% lower than BAR, Browning automatic rifle gunners, and 60% lower than forward observers, both roles that required similar exposure to enemy fire but at closer range. Survivor testimony reveals the bazooka's psychological impact on American troops. Sergeant First Class John McAllister, 29th Infantry Division, wounded in Normandy and medically retired in 1945, wrote in a 1987 letter to the U.S. Army Center of Military History, "The bazooka made you feel like you had a chance. Before we had them, seeing a German tank meant running or dying. After we had them, seeing a German tank meant business. We could fight back. That changes everything about how you feel walking into combat." Private Edward Sullivan, 3rd Armored Division Infantry Support, interviewed in 1979, described the weapon's reliability. "I carried that tube across France, Belgium, and into Germany. Fired it maybe 40 times in combat. Never once did it fail to launch when I pulled the trigger. Never once did the rocket fail to explode on target. You could count on it absolutely. In war, that's everything." Comparative analysis with Allied equivalents reveals American design superiority. The British PAIT, Projector Infantry Anti-Tank, weighed 14.5 kilograms combat loaded, nearly 3 times the bazooka's weight, and had effective range of only 100 meters. Its spring-launched projectile required cocking a heavy spring mechanism that took considerable strength, making it difficult to operate under stress. British forces eagerly replaced PAITs with American bazookas whenever possible. Field Marshal Bernard Montgomery personally requested increased bazooka allocations for British units in 1944, writing to Allied headquarters, "The American rocket launcher proves vastly superior to our own anti-tank weapons for infantry use." Soviet forces received approximately 8,900 bazookas through Lend-Lease shipments between 1943–1945. Soviet soldiers, already equipped with their own PTRD and PTRS anti-tank rifles, overwhelmingly preferred the American weapon. Red Army after-action reports from the Battle of Berlin in April–May 1945 credit bazookas with 127 German tank kills, remarkable considering how few Soviet units possessed them. The German Panzerschreck, while more powerful, 160 mm penetration versus the bazooka's 119 mm, weighed 11 kilograms versus 5.9 kilograms and cost significantly more to produce. German production totaled approximately 289,000 units between October 1943 and May 1945. Impressive, but 187,628 fewer than American production, despite Germany's desperate need for anti-tank weapons. The Americans simply outproduced them. The philosophical difference was fundamental. American military doctrine valued crew survivability.
The bazooka allowed infantry to engage armor from distance and concealment, minimizing operator exposure. Soldiers could carry the weapon plus substantial ammunition loads, providing sustained anti-tank capability throughout extended engagements. Training emphasized firing and relocating, shoot and scoot, to prevent enemy counter-battery fire. German doctrine, conversely, often treated infantry anti-tank weapons as last-ditch solutions. The Panzerfaust, Germany's other shoulder-fired anti-tank weapon, was single-shot and required operators to close within 30 meters of enemy armor, practically guaranteeing user casualties.
The Panzerschreck, while reusable, was heavy enough that most soldiers carried only 3 or 4 rockets into combat versus the bazooka's typical load of 6 to 8 rockets. Which approach succeeded? American infantry survived at higher rates, carried more anti-tank capability per soldier, and destroyed more enemy armor per capita than German infantry. The numbers are stark. American forces in Europe destroyed approximately 5,000 German tanks and assault guns using bazookas, with operator casualties estimated at 4,200 killed and wounded, a ratio von 1,19 Tanks destruiert per bazooka operator casualty. German forces using Panzerschrecks und Panzerfausts destroyed roughly 6,500 Allied tanks, with operator casualties estimated on 11,800 killed and wounded, a ratio von 0.55 Tanks destruiert per operator casualty. American bazooka operators were twice as effective per casualty as their German counterparts. The bazooka's unit cost, $42.50, meant America could afford losses that would bankrupt other nations' military budgets. When a bazooka was destroyed, another arrived within days from supply depots. When rockets were expended, more came forward in ammunition trucks. The American industrial machine ensured frontline soldiers never lacked the weapons they needed. By comparison, German Panzerschreck operators in late 1994 und Anfang 1945 oft operated with chronic ammunition shortages. After-Action Reports von der Schlacht der Bolsch note German Anti-Tank-Teams mit funktionalen Panzerschrecks, aber keine Rockets, unfähig die amerikanische Armor anzugreifen, obwohl sie die Waffen dazu hätten. American Logistics, paired with American Industrial Production, created einen militärischen Vorteil, den Germany keinerfalls überwinden konnte.
November 23, 1942. Major Klaus Hoffmann stood beside the disabled Panzer IV at Medjez el-Bab and understood he was witnessing the end of something fundamental. For 3 years, German armor had ruled battlefields because infantry couldn't touch them. The Blitzkrieg doctrine, fast-moving tanks supported by mechanized infantry overwhelming defenders before they could react, assumed that foot soldiers armed with rifles and grenades were helpless against steel armor. That assumption had conquered Poland in 28 days, France in 46 days, and driven deep into the Soviet Union in 1941. The circular hole punched through this Panzer side armor meant that assumption was now obsolete. American ingenuity had democratized anti-tank warfare. Every rifleman could now threaten armor. Every infantry squad possessed tactical capability that previously required specialized artillery units. The mathematics of armored warfare, the calculations that made tanks decisive, had shifted permanently. From November 1942 forward, armor could not advance without accepting that infantry might destroy it at any moment from any direction. The surrender connection was direct. When Nazi Germany surrendered on May 8, 1945, Wehrmacht forces possessed hundreds of operational tanks. They also possessed depleted fuel supplies, broken logistics networks, and infantry formations that had been bled white by 3 years of American bazookas, British Piats, Soviet anti-tank rifles, and German Panzerschrecks copied from the American design. The weapon that opened at Medjez el-Bab in November 1942 participated in the final battles of Berlin in April 1945. American-supplied bazookas in Soviet hands, helping to kill the last German tanks defending Hitler's capital. The final irony transcends military history. Germany, renowned for engineering excellence, for Tiger tanks and Panther tanks and revolutionary weapons designs, was shocked into paralysis by an American weapon that looked like a plumber's pipe.
The nation that produced Wernher von Braun's V-2 rockets couldn't comprehend how America had weaponized shaped charges and rocket motors into a man-portable system in less than a year. When German engineers finally copied the design, they over-engineered it into something heavier and more complex, proving they'd missed the fundamental lesson. Warfare rewards simplicity, reliability, and mass production over technical perfection. The lesson extends beyond the bazooka itself. American military success in World War II stemmed from the willingness to field good enough weapons in overwhelming quantities rather than perfect weapons in limited numbers. The Sherman tank was inferior to the German Tiger in direct combat, but America built 49,234 Shermans versus Germany's 1,347 Tigers. The M1 Garand rifle was simpler than German selective fire rifles, but American soldiers never lacked ammunition while German forces scrounged cartridges from the dead. The bazooka wasn't the world's best anti-tank weapon, but American infantry possessed 476,000 of them, while German soldiers made do with whatever they could find. Broader implications shaped military doctrine for 80 years. The United States military learned that speed of development, concept to battlefield deployment, matters more than technical sophistication. Better to field an adequate weapon immediately than a perfect weapon eventually. This philosophy drove Cold War weapons programs, shaped responses to asymmetric warfare threats, and continues influencing modern military acquisition today. The F-16 fighter, designed as a lightweight, simple, mass-producible aircraft, embodied bazooka philosophy. The M4 carbine, lightweight, reliable, ubiquitous, followed the same logic. The final judgment requires clear eyes. The M1 Bazooka was not the most powerful anti-tank weapon of World War II. It was not the longest range, or most accurate, or most sophisticated. German Panzerschrecks penetrated thicker armor. Soviet anti-tank rifles had longer range. British Piats fired heavier projectiles. But the bazooka was the most successful infantry anti-tank weapon of the war because it achieved the only goal that ultimately mattered. It gave foot soldiers the power to kill tanks. And enough Americans possessed them that German armor could no longer operate with confidence anywhere American infantry existed. 3,148 confirmed tank kills, countless more damaged or suppressed. Psychological dominance that shifted tactical doctrine. German engineering forced to acknowledge American design brilliance by copying it verbatim. All for $42.50 per unit. The examination of that damaged Panzer at Medjez el-Bab provided the first proof of something German commanders would spend 3 years learning. America's greatest weapon wasn't superior technology. It was the capacity to innovate rapidly, produce massively, and equip every soldier with weapons that worked. The bazooka didn't win World War II, but it proved the industrial and innovative principles that did. Major Hoffmann's sketch of that circular penetration hole, preserved in Wehrmacht archives captured in 1945, shows precise measurements. 115 millimeters diameter, clean entry, no fragmentation pattern. Beside it, he'd written one word in neat German script: unmöglich, impossible. But the Americans had done it anyway, and that, ultimately, is the entire story.